Hello everyone, my name is Rajan Kumar. Today I am going to discuss about the root locus. So today we are going to study. Today lecture is based on root locus. We are going to see what is the root locus, what is the basic property of root locus of any system. Now, this is root locus. Hello everyone. Today we are going to study about root locus. First we study some theory parts and then we solve numerical problem. Now say, what is the root locus? Root locus is the locus of poles of closed loop system. Means if I have a closed loop system, for example, say like a CS divided with 1 over RS, GS divided with 1 plus GS HS, right? This is the closed loop system. Now what is the pole of this closed loop system? If we make the GS HS equal to 0, then when the roots of this equation is known as the pole of the system. The roots of this equation is known as the pole of the system. Same then the path of, we can say the locus of the roots, if there is some roots are there, the path of these roots, these roots are known as the root locus. Okay. Now second point say that the locus closed loop system with a gain margin, means root locus is the locus of closed poles of closed loop system. Means there is the locus when we with gain k, means if you change the gain of the system, then these roots are changed, the value of these roots are changed, and the path followed by these roots is known as the root locus. Root locus only say the absolute stability. What is the absolute stability? When the stability of system decided by location of poles and 0, then that stability is known as the absolute stability. By location of poles and 0, if by location of poles and 0, if you decide the stability of the system, that and so it is known as the absolute stability. Means root locus for we assume that if we design a root locus of any system, then we assume that number of poles in that transfer function of the system, number of poles and number of 0 of open loop transfer function of that system is equal, are equal. So number of poles and number of 0 of this let us consider transfer function like this, GS HS is equal to k divided this into s plus 1. Now number of pole in this transfer function is 2, and number of 0 in this transfer function is 0. But we assume that there are 2 0 at infinity. Means number of poles and number of 0 in this transfer function are equal. But these 2 zeros at infinity, we assume that there is 2 0 at infinity. That is mentioned in our third line here. Say that for root locus, that order of pole means number of pole equal to the number of 0. And this is the condition why at infinity we assume that there is a transfer function, value of the transfer function is 1. If the value of transfer function is 1, if you multiply transfer function with 1, there does not change any, there is no change in the overall transfer function here. So we assume always for root locus there is number of poles and number of 0 are equal in our open loop transfer function. What is the for negative feedback? Here we see for negative feedback and for positive feedback. Designing of root locus for negative feedback and positive feedback. What is the originating point? Originating point nothing but from where roots are started. We can say from where roots are started. The roots always started from open loop poles. At this point, open loop pole, the value of k, or we can say DC gain, is always 0. and roots are always terminated. Roots are always terminated at open loop 0, and at this point the value of k, or we say DC gain, tends to infinity. Means in previous example, when I say s is equal to GSHS is equal to k divided with s into s plus 1, like this, we assume that there are poles are there are poles, these are the poles at s is equal to 0 and s is equal to minus 1, these are the poles, and 0, we assume that there are 2 0 at infinity. At the poles, the value of k is, at this point s is equal to 0, the value of k is 0. At s is equal to minus 1, the value of k is 0. But at the poles, at the zeros, which are located at infinity, the value of k tends to infinity. The value of k tends to infinity. Clear? That are mentioning is this is the terminating point. Now, existence of root locus on real axis. On the real axis, root locus always, if this is the real axis, like sigma plus j omega, and these are the poles and zero. Right? Now, root locus exists here or here or here. The existence of root locus is always see here in second one, existence of root locus, odd number of open loop poles and 0 toward the right side. Means odd number of open loop poles and 0 towards the right side. Means if I am standing here, the number of poles in right side is 1. That is the odd number. Means we can say root locus can exist between these regions, because there is the odd number of poles. But when I am standing here, then I see there are 2 poles in right hand side. Means root locus cannot exist between these regions. And when again I am standing in this region, then I see there is odd number of poles and 0, means root locus also exists in this region. On real axis, this is for only for real axis here. Now, this is the existence of root locus on the imaginary axis, real axis. Sometimes it is total angle subtended by this, the odd multiple, the odd integral line. See here. Now angle subtended by at this point, if I am staying here, if this point is 180, right? If I say angle subtended by all of the pole at this point is, for this is the 180, for this is the 180 also, means 360 degree. Or this is the not odd multiple of 180, this is the even multiple of 180, means root locus cannot exist at this point. Clear? Always remember that if I am standing here at see right hand side, if there is odd number of poles and 0, then roots are exist here. If there is even number of poles in 0, then roots are not exist in this region. Now see next. Now existence of root locus in complex plane. This is very easy. Means in previous case we see the existence of root locus on real axis, but I am saying that if there are the pole is here, this is the complex plane of which complex plane. This is the complex plane. But if the root locus exists at this point or not, then what happen? We just draw a line from this poles, from this point, or say the angle is A, and again draw a line from this poles and say the angle of B. This is the B. Existence of root locus in a point. There is the point in complex point here, complex plane. This is the point here mentioned already. Means if the angle A and angle B is odd multiple of 180, then root locus can exist at this point. If angle B, A and B summation of not equal to the odd multiple of 180, then root locus cannot exist at this point. Clear? This is for negative feedback, and similarly for positive feedback, your value of k less than 0, that should be even multiple of 180. This angle should be even multiple of 180, like this. Now breakaway point. What is the breakaway point? When root locus start moving on real axis, then two possibility will be happen. That are two possibility. When there is the poles are there, okay, or when there is the zeros are there. There is a possibility of maybe poles are there, maybe poles are there. These are the poles. These are the poles, and maybe these are the zeros. There is the two possibilities here. When we increase the value of gain, then the roots start travel in this direction, and this root start travel in this direction. Clear? When you increase at this point the value of k is 0, we already know that. At this point value of k is 0, we already know that. And at 0 the value of k is infinity, means terminating point. The value of k at this point is infinity. Clear? Now when we increase the value of k, then root locus start moving toward each other, or they may be collide at this point. They may be collide at this point. Clear? They may be collide at this point. After collision, this is a root to break into the two part and goes and like this and terminate at the 0. Root always are terminated at 0, goes like this and terminate 0. Means this path goes like this, and that one, this path is goes like this branch is like and terminated at 0. Then what happens here? Root locus goes branch break into two part and goes in complex plane. Means branches roots are going from real axis to the complex plane. Real axis to the complex plane. Right? Means here roots are moving real axis to complex plane. Here our roots are moving, but here see here, when we increase the value of k, then our roots are start moving like this, coming like here, and this from here. When we increase the value of k, then roots maybe go like this, and here roots goes like this and terminate here, and here goes like this and terminate here. Means these roots is goes like this and terminate here. Clear? Now what happened at this point? This terminated. Now here the roots are moving from complex plane to the real axis. The roots are moving from complex plane to the real axis. If roots are moving from complex plane to real axis, then this point is the meeting point. This point is known as the break-in point. Break-in point. If roots are moving from complex plane to the real axis, on the real axis, then this point is known as the break-in point. If roots are moving away from real axis, then this point is known as the breakaway point. Breakaway point. Breakaway point. This point is known as the breakaway point, and this point is known as the break-in point. Now, sometime it is said that okay, and breakaway. Let some. Where is the 1 second? I need some extra software here. Focus point like this. Okay. The roots are, this is the breakaway point, or this is the break-in point. Right? What happens if we increase the value of k from 0 and goes increasing and increase up to the infinity, then roots goes like this. Then when if I am increasing my value like k is equal to 0, now put again increase k is equal to 1, k is equal to 2, and goes like this at k is equal to 6. So you are going at this point at k is equal to 6. Then what happens if we again increase the value and put k is equal to 7, then what happens? Roots break into the two part and goes away from the real axis. Means at point 6 is the maximum value of k for which root locus lies on real axis. Understand that? Now similarly for this condition, if from at the pole value of k is 0, at the pole value of k is 0, and at the 0 value of k is infinity, at the 0 value of k is infinity, we know that at terminating point value of k is infinity. When we increase the value of k from 0 to 6, then what happens? When it's 0, to 6. At 6, the roots come from complex plane to the real axis, on the real axis. Now, when we further increase the value of k7, then roots start move like this. Means 6 is the minimum value of k for which root locus means root locus lies on the real axis for each. Now see, for this condition, root locus is lie if k is 7 or 8, 9, 10, then root locus always lies on real axis. But at k is equal to 6, the root locus is at this point, roots are at this point. But if the value of k less than 6, then root lies in this region. Means k is the minimum value k, the 6 is the minimum value of k for which roots are lie on real axis. Means if we increase the value of k 7, 8, 9, 10, the roots always lies on the real axis. So it is mentioned here, this is the minimum value of k for which root locus lies on the real axis for here. And for this, if I want to write like this, so we can write like this, k is equal to 6. Now see here, and k is equal to 7. This is the k is equal to. For this condition, I am writing again. For this condition, when k is equal with value of k less than 6, then roots are in complex plane. Roots are in complex plane. Clear? When k is greater than 7, then roots are on real axis. Clear? Or for this condition, see here, when k is less than 6, then roots are on real axis. Real axis. When k is greater than 6, then roots are on in complex plane. Roots are in complex plane. Means where here k is the maximum value for which roots are lie on the real axis, and for here k is the minimum value for which roots are lie on the real axis. Clear? Now, so I mentioned it is the minimum value of k for roots located on the real axis. Clear? K is the less than, if the k is less than the minimum value, the roots will be remain in complex plane. Obviously, I have said that if the k is less than the real value, less than this real value, then roots are in complex plane. Roots are in complex plane, or that is the breaking point. I am discussing about this one. That is the breaking point. And so whenever roots locus is shifted from complex plane to real axis, always breaking point is exist. Clearly, means when roots are shifting from complex plane to the real axis, there is the breaking point. If our roots are shifting from real axis to the complex plane, that is the breakaway point. Okay. Take this one on the next slide. This is the breakaway point. Go to the next slide here. And, this is the breakaway point for this is the calculation for breakaway point. See here. Now, we already explained that what is the breakaway point. There is the maximum value of k. Now the maximum value of k for root locus lie on the real axis. See here, when value of k less than 6, then root locus are on the real axis. But if the value of k greater than 6, then root locus goes into the complex plane. And now this point is important for us. Shifting from real axis to the complex plane, there is the known as the breakaway point. This is the known as the breakaway point. My question is now next question is it how we can calculate the break-in and breakaway point. How we calculate the break-in? The calculation of break-in and breakaway point both are same. Now see how we calculate the break-in and breakaway point. Now let's consider our example. Our example is GSHS is equal to k divided with s into no video existing k divided with s into s plus 1. Okay, this is our example. Now in first line student, find the value of k from characteristic equation in terms of s. See here, find the value of k from the characteristic. Now write the characteristic equation, then find the value of k. 1 plus, we know that this is the characteristic equation. Then find the value of k from this characteristic equation in terms of s. Put this one in right hand side, then we can write k is equal to minus s into s plus 1. Clear? Now what is the k? What is the k? That is s square plus s. We all find the value of k in terms of s. Now differentiate the del k over del s is 0. Means first we have to find what is the del k over del s. First we find del k over del s. Here del k over del s is equal to 0. Del k over del s, sorry. Now 2s minus 2s plus 1 del k over del s, and set the del k over del s is equal to 0. Set the del k over del s is equal to 0 means 0, we can say plus 2s, sorry, plus, this should be plus, no, minus 2s plus 1 is equal to 0 means s is equal to minus 1 by 2. Means s is equal to minus 1 by 2 is the breakaway point. See here, what is the value of this quantity? S is equal to minus 1, right? This is s equal to minus 1. See here, poles are from s is equal to 0, the another poles is 0, s is equal to 0. But this point is breakaway point, and here the value of s is minus 0.5. Obviously, this point are existing between 0 and minus 1. This may be minus 0.5 from our calculation. So this is the breakaway point. This is the breakaway point. Now same point for previous case, same point for previous case if we calculate, and same point for previous case is considered for breaking point. Because here root locus is coming from complex plane to the real axis, or here root locus is going from real axis to the complex plane. This is the breakaway, this is the breaking. The basic difference between breakaway and breaking point is only where the root locus going away from real axis to the complex plane, or complex plane to the real axis. If roots are coming from complex plane to the real axis, then that point is known as the breaking point. Okay. Now, so next is the centroid. What is the centroid? First we are going to study what is the asymptotes. Asymptotes are those branch in root locus which are going to terminate at infinity. In starting we studied that our root locus started from pole and terminated at 0. But if our roots are started from pole and goes like this and terminated at infinity, where there is started from pole and terminated at infinity, where there is the imaginary 0. There is not exactly 0, but there is the imaginary 0. Then this branch is known as the asymptotes. Or maybe there is the imaginary poles at infinity, and roots are started from imaginary poles and terminated at real 0. Then this branch of root locus is known as the asymptotes. This branch of root locus is known as the asymptotes. See here, already mentioned it, the branch which is terminating at infinity or originating from infinity. The branch which is terminating at infinity, termination means there is the virtual 0. We can say the virtual 0, or there is a virtual pole, or originated from infinity. If at infinity there is a virtual poles, then branch is originated and terminated at 0, real 0. Then this branch is known as the asymptotes. But this branch is not known as the asymptotes, right? This branch is not known as the asymptotes. Now, when there is the asymptote, then we have to calculate what is the centroid, means from where this asymptotes, angle of asymptote. Now see the centroid, means what is the direction of this asymptote. Means if there is the pole is here, or there is imaginary 0 at infinity, then the branch may be started from here and goes like this, clear, and terminated at infinity, clear. Other option is that maybe the branch started from here, goes like this and terminated at this point. The other maybe possibility is that the branch may be started from like this and goes like this and terminated from infinity. Asymptotes say that the branch which is terminated at infinity or originated at infinity. Here see, all the branches originated from pole and all the branches terminated at infinity. But each and every branch have different path, different direction of termination and originate a different direction. If the branch have different direction and different path, how we can decide the which branch going to the which path, means what is the path, how we decide the path of the branch. Asymptotes means for deciding the path of the asymptotes, or we can say the direction of asymptotes, we have to calculate angle of asymptotes and centroid. Centroid is whatever from these asymptotes are started. From these asymptotes are started, clear. Angle of from where angle of asymptotes are started, sorry, not asymptotes, angle of asymptotes means angle is known as the direction, means from where direction of asymptotes are started, means there is the something centroid, or centroid say that this asymptote goes in theta is equal to 60 degree, this asymptote goes in theta is equal to 40 degree, means this asymptote goes theta is equal to 60, this asymptote goes as theta is equal to 40 degree. This is decided by the centroid and angle of asymptotes. Centroid and angle of asymptotes, it gives, it both to give the direction of the asymptotes. Centroid is nothing but the sum of real part of pole minus sum of real part of 0, means if we have a pole plus 3j, for centroid calculation we only consider minus 2 because 3j is not a real part. See your number, this is the sum of real part of pole. Similarly, this is the sum, this should be sigma z, sum of real part of 0, this should be sigma z is here. Similarly, like this quantity, this should be sigma z. Sum of real part of 0 means we only consider the real part here, and p minus z is number of pole and number of zeros or our transfer function. Similarly, for angle of asymptotes, for positive feedback or negative feedback, k greater than 0 and k less than 0, these are the angle of asymptotes, where q is q is 0 1 2 3 4 and goes like p minus z minus 2, means if I have a transfer function like this, k divided with s into s plus 1, then what is the p? P is the 2, there is 2 poles, and what is the 0? There is no 0. Then q goes to 0 1 dot 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 2 my p minus z minus 1, means 2 0 1, because the maximum limit of q is 1, so q goes to from 0 to 1. So this is the q goes to 0 to 1. Clear? This is the limit of the q. Q limit decided by number of pole minus number of 0 minus 1. Okay. Now number of asymptotes are these. Number of asymptote is always calculated by difference between, just remember this line, and not this is not so important here, the difference between number of pole and number of 0, but just remember this line. Number of asymptote is difference between number of pole and number of 0, means means here 0 is 0 and here pole is 2, means difference between pole minus 0. For some, if our function look like this, k s plus 1 s plus 2 maybe, and this is s plus 3, number of pole is 1, number of 0 is 2. Then difference between pole minus 0, z minus p, obviously z is greater than p, 2 minus 1 means 1. There is one asymptote goes, there is one asymptote here, means one branch goes to the infinity. Clear? So just remember this line only, ki what number of asymptotes. Number of asymptote is difference between number of poles and 0. Now next slide is angle of departure. Angle of departure always calculated for complex conjugate poles. Means if our poles is 3 minus 4j plus 4j, 2 plus 3j, and uh, 2 minus 3j, then and minus 5 minus 6, something like this, then we cannot calculate angle of departure for this pole, we cannot calculate angle of departure for this pole, and we cannot calculate angle of departure for this pole. We only calculate the angle of departure for the complex poles, only for complex pole. Or this is the formula for calculation of angle of departure for negative and positive feedback. If there is a value of k is greater than 0 and if the value of k is less than 0, this is the formula. Phi z is nothing but total angle subtended by remaining 0 towards the complex pole whose angle of departure is calculated. Means अगर मैं इस पॉइंट पे एंगल ऑफ डिपार्चर कैलकुलेट करना चाहता हूँ, राइट, तो अदर पोल, इस पोल ने यहाँ पे कितना एंगल सबटेंड किया a और इस पोल ने कितना एंगल सबटेंड किया b, और फॉर एग्जांपल यहाँ पे एक 0 है तो इसने कितना एंगल सबटेंड किया c, तो एंगल ऑफ डिपार्चर क्या होगा एट दिस पॉइंट एंगल ऑफ डिपार्चर 180 माइनस 5z मीन्स सम एंगल सबटेंडेड बाय 0 c, और एंगल ऑफ डिपार्चर प्लस दिस शुड बी प्लस or minus angle subtended by poles. What is the phi z? Angle subtended by pole, bracket a plus b. We calculate in our numerical problem. Just remember this formula. This is the very important formula here. And what is the phi z and what is the phi p? Remaining pole toward the complex pole, right? From toward the complex pole. Now this is the from remaining zeros, and this is from remaining poles like this. I have already shown you. Now next is this is the last slide here. Now the next is the angle of arrival. Similarly, in angle of departure calculated for poles, right, and angle of arrival calculated for zeros of the system. If similarly like this, if 0 are minus 2 plus 3j minus 2 minus 3j plus 4j minus 4j, then minus 6 and minus 7, then we only calculate the 0 for, we cannot calculate the angle of arrival for these zeros, because we calculate the angle of arrival for complex conjugate zeros. Means we calculate the angle of arrival for these zeros, for these zero, for these zero. Similarly like this, only change in this formula is negative sign. See here, only change in formula is this negative. There is a plus sign here, or here is the minus sign is there, here is the minus sign is there. Clear? A little bit change here. All quantity are same. All quantity are same. Now sometime it is asked what about the in root locus, what is the gain margin. Sometime in question they ask what is the gain margin of the any system. And from the root locus there is the different method to calculate the gain margin, but from root locus how we calculate the gain margin. Just consider example in our question. If given that if at k is equal to 6, system is marginally stable. In question marginally stable. In question is given that we solved a number of problem on the basis of this formula, but just consider example. In question given that at k is equal to 6, system is marginally stable, right? And asking that if system is marginally stable, then gain margin is 0 dB. We know, or if we don't worry about this, we will study this terms also, what is the gain margin and why it is 0 dB. But just remember that if system is marginally stable, then gain margin is 0 dB. Means say that at k is equal to 6, system is marginally stable. Then find the gain margin of the system when k is equal to 9. At this point, when k की value 9 होगा, उस condition में gain margin क्या होगा? For this, there is the equation here. For this, k margin means value of k when system is marginally stable. Means value of k when system is marginally stable is 6. See here, already given. And k desired is nothing but at which value of k we are going to calculate the gain margin. So and that is the 8. 9 here is 9, here our value is 9. Okay, just ratio of this two quantity, this 2 by 3 means 0.666 is the gain margin of the system when value of k is the 9. Clear? Now in next class we study we solve a number of problems on the basis of this root locus. Just quick revision is there. There is a quick revision of all the slides here. We generally root locus used for closed loop system, and we always used it give always absolute stability. And for the system has equal number of poles and zeros. Now that is for negative positive feedback system root locus के लिए originating point system always root locus start कहाँ से होता है, पोल से स्टार्ट होते हैं. पोल पे के की वैल्यू क्या होती है, 0 होती है, और टर्मिनेट कहाँ पे होता है, 0 पे टर्मिनेट होगा, और 0 पे के की वैल्यू क्या होगी, डीसी गेन के की वैल्यू क्या होगी, इन्फिनिटी होती है. नाउ इस और एग्जिस्टेंस ऑफ रूट लोकस जस्ट रिमेंबर दैट, क्योंकि राइट साइड में हमारे क्या होना चाहिए, ऑड नंबर ऑफ पोल्स एंड 0 होने चाहिए. उस रीजन में रियल एक्सिस के उस रीजन में रूट लोकस एग्जिस्ट करेगा. अगर ऐसा नहीं है तो रूट लोकस एग्जिस्ट नहीं करेगा. फॉर नेगेटिव फीडबैक के लिए, पॉजिटिव फीडबैक के लिए इवन नंबर होना चाहिए, राइट. ओके, एग्जिस्टेंस ऑफ रूट लोकस इन कॉम्प्लेक्स प्लेन. हमने क्या स्टडी किया कि अगर इस कॉम्प्लेक्स पॉइंट पे रूट लोकस एग्जिस्ट होना है तो उसके लिए अदर जो भी हमारे पास पोल्स और जीरो हो जाए वो एंगल यहाँ पे सबस्टेंड कर रहे हैं यहाँ पे, तो टोटल एंगल का समेशन क्या होना चाहिए, ऑड मल्टीपल ऑफ 180 फॉर नेगेटिव फीडबैक एंड इवन मल्टीपल ऑफ 180 फॉर पॉजिटिव फीडबैक होना चाहिए. हमने ब्रेक अवे ब्रेक इन पॉइंट को स्टडी किया. ब्रेक अवे पॉइंट क्या होता है, जब रूट लोकस ब्रेक इन, हियर इज द ब्रेक इन पॉइंट. व्हाट इज द ब्रेक इन पॉइंट, व्हाट इज द ब्रेक इन पॉइंट. Break-in point when root locus is coming from complex plane to the real axis, that is the break-in point. What is the breakaway point when root locus moving from real axis to the complex plane? That is the breakaway point. We already studied it. We can calculate the break-in and breakaway point from this method. This is step, and we can also calculate the centroid here. We have already seen what is the centroid and how we can calculate the centroid. And also next is we see and next slide we see what is the angle of departure and what is the angle of arrival, and also we see what is the gain margin of the system. Next class we will solve a number of problem on root locus. Thank you.